These beautiful hills of Chikmagalur and Kodagu districts in Karnataka, dotted with undulating estates of coffee, make a pleasing sight. These coffee estates convey a well-being associated with a carefully nurtured environment, untarnished by unmindful destruction. But reality is something else.
Coffee growing, being intensive,
generates abundant of dark-colored, foul-smelling effluent during the pulping season. Effluent, although doesn't have any toxic constituents, when discharged into water untreated, depletes the oxygen level in water. The purity of water is assessed in terms of biological oxygen demand, or BOD. If the BOD in water exceeds acceptable limits, it has many undesirable consequences. The water loses its ability to support essential life forms. The discharge of decomposable organic waste makes it acidic and dense with solid organic matter. Discoloration and foul smell of water are visible and evident. These effluents can encourage the growth and life of low-level pathogens. It stimulates the growth of weeds and algae in the stream and can block the inlet flow of water in streams by clogging the water channels. Water in stream receiving untreated effluent becomes unsuitable for irrigating coffee.
Basically, wet processing of coffee comprises of two processes. The first stage is where the coffee is fed into a machine called a pulper, where the seed, the coffee bean, is separated from the fruit. The skin of the fruit goes out with the water into a channel that side. The second part of it is where the seed falls into this washing machine over here, where the seeds are washed thoroughly through this particular machine. It comes out there and it's fed into a vat, where it's kept under fermentation for a day and then put out into the drying yards to dry.
The Karnataka State Pollution Control Board made it mandatory on part of coffee estate owners to implement methods to arrest pollution by coffee effluents. The Karnataka State Pollution Control Board has recommended effluent treatment through lagoons, where effluent was first treated in anaerobic tanks and then in aerobic tanks or lagoons. But this process took too long and was expensive. And also, the treated effluent did not have the acceptable BOD levels. In an attempt to solve this problem, Astra from IISc attempted to develop a technology. This technology enabled the estate owners to treat coffee effluent in simple, low-cost manner with minimum maintenance and provided an energy alternative called biogas. This technology was called bioreactors for clean coffee effluents. This technology comprises of constructing bioreactors on the coffee estates, which works on the principle of anaerobically digesting the organic matter in the effluent to a combustible gas, biogas, that contains methane and carbon dioxide. A bed of partially digested biomass, that is, a mixture of cow dung and biomass, is composted in a separate pit and introduced into the reactor prior to the effluent treatment as a seed for the digestion process. This needs to be done only in the first year. In the reactors, the organic compounds of the effluent are broken down to form biogas. Water with lower BOD level is released from the outlet pipe. The digested organic material can be manually lifted out and used as manure. This process prevents the organic matter in the effluent from reaching the streams and thereby arrests pollution. These reactors need lesser investment and lesser space and provide biogas as an alternative energy source, and the treated effluent has most acceptable BOD. The biogas generated by this process can be used for running machines during pulping season, washing units, sprinklers, as well as cooking and lighting in the estate. These efforts made by Astra are completely supported by INEP.
Now imagine that the 40 kgs of the sugar that we are letting into the stream is now converted to methane, that is biogas. We roughly get about 20 cubic meters to 30 cubic meters of biogas from every ton of coffee that we process. This is equivalent to collecting 15 liters of diesel every time we pulp 1 ton of coffee berries. In addition, 95% of the pollutant is now not let into the stream. So on the one side, we are not letting in the pollutants into the wastewater. On the other side, now we are harvesting equivalent of 15 kilograms of diesel for every ton that we pulp. And this is the major benefit one gets. Today, thanks to a large number of well-wishers like the Coffee Board, the Pollution Control Board, the Indo-Norwegian Environment Program, and the Environment Department itself, a large number of demonstration plants have been built in the field and they have been functioning. Many people, especially the pioneer planters, have taken it up and have been operating this for nearly 5 years.
Through this partnership, INEP supports innovative experiments that provide sustainable solutions and create awareness among larger environmental concerns. These bioreactors for coffee are also used with certain modifications for treatment of urban solid waste. Currently, with the help of INEP, Astra has constructed 4 pilot plants, and the benefits are already evident, as can be witnessed by the coffee estate owner's own words.
Actually, I see so many benefits of this system. For starters, the Pollution Control Board has prescribed huge lagoons and tanks which are not only very expensive to maintain, they have very limited usage. You can use them only for pollution treatment and only for a few months in the year. Now this has got a multi-utilitarian angle to it, because you don't use it just during your coffee season. You can use it right through the year, because you can feed it with biomass, leaf, litter, you can put plant trimmings into it and any kind of organic material. Besides, this plant was also much cheaper to build compared to the conventional pollution treatment plants prescribed by the Pollution Board. Besides, this bioreactor has year-long utility which the other pollution systems don't have. They are specific only to coffee, and you cannot get any other utility out of them. They occupy a lot more space than this system. This is much more compact, so you save on valuable land, and this is also much cheaper to build. Then of course the biogas, I mean at today's fuel costs, I've also already mentioned that it's a huge saving for us. Then there is the organic side, where you get out your liquids and your solids from this side of the reactor, which are very rich organic manures, and we use them on our estates, and we've had very good results. We also find ourselves being recognized as eco-friendly people today, and that's becoming a criteria for most agriculturalists, and it will help to market our coffee internationally in a better fashion. So I look at this bioreactor in a multifaceted way, and I am grateful to the Indo-Norwegian Environment Program, which set up the system for us at a time when coffee was doing very badly, and I do hope more coffee planters adapt this model.
By installing bioreactors for clean coffee, the estate owners can create a new image of being environment friendly and reinforce their reputation as a socially responsible community.